Hello and welcome to Algebra 2, Lesson 77. In this lesson, we're going to learn about graphing ellipses. So in the last lesson, we learned how to graph a circle. So it turns out that a circle is just a special case ellipse where the distance from the center to any point is the same. And remember, we had a special name for this distance from the center to any point. We called this the radius. So kind of looking back on that lesson, we saw that if we had a circle that was centered at the origin, it followed the equation x squared plus y squared equals r, which stands for the radius, squared. So if I looked at x squared plus y squared equals 4, I know this is the radius squared. So if I wanted the actual radius, I would take the principal square root of that, and that would give me 2, right? Square root of 4 is 2. So my radius is equal to 2. Now, I already told you this is centered at the origin, so we can say our center is at 0, 0. But the way you can tell it's centered at the origin, if you just have x squared and you just have y squared, so you don't have x minus something or x plus something and that's squared, you don't have y minus something or y plus something squared. When you just see x squared and y squared, this guy is centered at the origin. So to graph the circle, we learned that we started at the center. In this case, that's at 0, 0. So that's right there. Then remember, the radius is a distance from the center to any given point on that circle. What we can do is start at the center and move to the right by the radius and make a point. We can move up by the radius and make a point. We can move to the left by the radius and make a point. And we can move down by the radius and make a point. So once we have those 4 points there, we can sketch a smooth curve through the points, and we've just graphed our circle. Then as we move into circles a little bit more, we see that not every circle is centered at the origin. So if we deal with a circle that's been shifted, then what happens is we have the equation x minus h, this quantity squared, plus we have y minus k, that quantity squared, and this equals the radius squared. So to think about where the center would have moved to, if it follows this format where you have a minus some h, and then you have a minus some k, the center will occur at h comma k. So in this case where we have the quantity x minus 3 squared plus the quantity x minus 2 squared equals 4, where's my center going to be? My center will have moved to 3, 2. Again, when it matches this format, I have a minus here. So I'm just going to take this 3, and that's going to be my x value. Here I have the same format, so minus something. Here I'm going to take that 2, and that's going to be my y value. If you run into the scenario where you have a plus sign, you need to convert it into minus some negative value. That way it matches that formula. Okay, so you have to do that. But this guy, it has the same radius as the last one we looked at. If I take the principal square root of 4, I get 2. So the radius is equal to 2. So essentially everything is the same. It's just been shifted 3 units to the right and 2 units up. My center was right here at the origin, but it moved 1, 2, 3 units to the right and 1, 2 units up. So this is my center now. And all the other points did the same thing. But again, when you're graphing this guy, you just want to look at the center, which is 3, 2. And then again, you make your points with your radius. So I go 2 units to the right, make a point, 2 units up, make a point, 2 units to the left, make a point, 2 units down, make a point, and then I sketch my smooth curve through the points. Now I just want to show you this one so that you can see how it's shifted. So given the fact that they both have the same radius of 2, this guy right here, again, has been shifted 3 units to the right and 2 units up. So my center went from here to here. 3 units right, 2 units up. You can take any given point. So you can take this point right here and say I went 1, 2, 3 units to the right, 1, 2 units up. The impact here again is that for a given point that was on that original graph that we looked at, x squared plus y squared equals 4, it's now been moved 3 units to the right and 2 units up. All right, so now that we understand the basis of how to graph a circle, we want to move into the ellipse. So graphing an ellipse is not any more difficult than graphing a circle. Once you learn how to graph a circle, graphing the ellipse is pretty easy. So when we see an ellipse, we generally think of a squished circle. So it may be tall and skinny in the case of a vertical ellipse, or it may be short and fat in the case of a horizontal ellipse. So the first ellipse we're going to look at is x squared over 9 plus y squared over 25 equals 1. So this type of ellipse is known as a vertical ellipse. You can see that it's tall and skinny, okay? And you'll see an example in a minute where it's going to be short and fat, but this guy is a vertical ellipse. I want you to notice something. This is what makes this a vertical ellipse. This guy right here, this 25, the denominator under the y squared is larger than this 9 here, the denominator under the x squared. Think about the fact that y is the vertical axis. Okay, it's the vertical axis. So when this guy is bigger, you'll get a vertical ellipse. I want you to notice something real quick. Let's say that I told you we wanted to find the y-intercepts here. How would we do that? Well, we'd plug in a 0 for x, so this would go away. I'd have y squared over 25 equals 1. That's easy to solve. Y squared over 25 equals 1. I can multiply both sides of the equation by 25 and get y squared equals 25. Then I'll take the square root of this side and then plus or minus the square root of this side. So y is equal to plus or minus 5. Now, with the y-intercept, we know that x is 0. So that's what leads to the points 0, 5 and 0, negative 5. Okay, those are right here. For the x-intercepts, I would do the same thing. I would just plug in a 0 for y, and I would solve for x. You'll find that you would get 3, 0, and you would get negative 3, 0. So here and here. So what's creating this shape is the fact that the distance from the center to this 5 up here, this is 5 units. This right here is 5 units. Then your distance from this guy right here to here, well, this is only 3 units. This is only 3 units. The fact that when we graph this guy, we're drawing a curve through these points, we have to go further in the vertical direction than we do in the horizontal direction. And so that's what creates this shape, this vertical ellipse that is tall and skinny. Now let's take a look at a horizontal ellipse. So in this case, I've just switched the denominators around. Now the 25 is underneath the x squared, the 9 is underneath the y squared. So the intercepts kind of just changed around. So now the x-intercepts would be at 5, 0 and negative 5, 0. The y-intercepts would be at 0, 3 and 0, negative 3. So this guy changed from being tall and skinny to short and fat. In other words, the distance from here to here is now 5 units. Whereas the distance from here to here is now only 3 units. So as this guy gets graphed, again, we draw our curve. It's a further distance horizontally when this curve is being drawn than it is vertically, right? So it creates this shape of being short and fat. So when you start working with ellipses, you're going to see 2 different standard forms. This can be a little bit confusing at first, but it's something you will get used to. When a vertical ellipse is centered at the origin, it has the equation x squared over b squared plus y squared over a squared equals 1. Now we talked about the fact that a vertical ellipse has a bigger value here underneath y squared than here. And the reason for that is we always want to have a being greater than b, okay? So if the denominator under y squared is bigger, you're going to use this formula here. This is for a vertical ellipse. In the case where we have a horizontal ellipse, well, when a horizontal ellipse is centered at the origin, it has the equation x squared over a squared plus y squared over b squared equals 1. In this case, we said with a horizontal ellipse, this is greater than this. Again, you've got to set this up to where a is greater than b. This has to do with a formula you're going to deal with down the road. When you really start talking about ellipses, you're going to see for the purposes of subtraction, a is going to need to be greater than b. So that's why these formulas are going to kind of switch back and forth. All right, so how do we graph an ellipse? Let's start out with the easy scenario where it's centered at the origin. So we have graphing ellipses centered at the origin. we first want to find and plot the x and y intercepts. Then we just sketch the graph, draw a smooth curve through the points. So just like we saw when we graphed a circle, we'll end up with 4 points, and we just draw a smooth curve through the points. All right, so let's start out with this first example. We have x squared over 9 plus y squared over 49, and this equals 1. So the first thing is, how do we find our x-intercepts? And let me make that a little better. And how do we find our y-intercepts? Well, this concept has not changed from when we first learned it when we were working with linear equations and two variables. Essentially, if I want the x-intercepts, I want to make y equal to 0. I want to make y equal to 0. And I want to solve for x. So I know that it's something comma 0 in each case, right? Because y is 0. So if this is 0, this is gone, right? 0 squared is 0. 0 over 49 is 0. It's gone. So we have x squared over 9 is equal to 1. I multiply both sides of the equation by 9. And we know that this would cancel with this. And I have x squared is equal to 9. Now, to solve this for x, I take the square root of this side. I take plus or minus the square root of this side. And I get that x is equal to plus or minus 3. So the x values when y is 0 would be positive 3 and negative 3. Now, what's the shortcut here? Because I don't need to go through this every single time. What ends up happening is, if this guy right here is a 1, which it's always going to be in the case of an ellipse, sometimes you'll get an equation that you have to put into this form, but once it's put into this form, this is what you're going to see. So what happens is, if this is always gone, let's just say this is x squared over q. Doesn't matter what q is, it's just a placeholder for now. And this equals 1. Well, I'm always going to multiply both sides of the equation by q. So I'll have x squared equals q. And to solve this, I'm going to take the principal and negative square root of q every time, right? So x would equal the positive and negative square root of q. So to get the x values for the x-intercept, I just need to look at this denominator here and take the principal and the negative square root of that. I don't need to go through plugging in 0 and doing all this work, because in every situation, that's what's going to happen. The same thing goes for finding the y values for the y-intercepts. I already know that the x values are 0. Right? I don't need to guess on that. So if I went through the whole thing, I'd plug in a 0 there. This would be gone. I have y squared over 49 equals 1. I multiply both sides of the equation by 49. That cancels. I get y squared is equal to 49. Again, I take the square root of this side plus or minus the square root of this side. So we get y is equal to plus or minus 7. So 0, 7, and then 0, negative 7. But again, the shortcut would be to just take this guy right here and say, okay, for the y values for my y-intercepts, I just take the principal and the negative square root, and that's how I get them, right? Positive or negative square root of 49 would be plus or minus 7. So once we have the intercepts, the process is very, very easy. It's just like graphing a circle. We just plot the points, and then we sketch a smooth curve through the points. So let's take these points down to the coordinate plane. All right, so we have everything kind of pre-drawn just to make it a lot easier for us. So here's our points. We have the x-intercepts that occur at 3, 0 and negative 3, 0. So here's 3, 0 here. Here's negative 3, 0. So those are 2 points. Then my y-intercepts occur at 0, 7 and 0, negative 7. So here's 0, 7 and here's 0, negative 7. And then I just need to sketch the curve around those points. So you can see the computer did a perfect job. I'm going to trace over what they did, and I will attempt to do a mediocre job. All right, let's take a look at another one. So we have x squared plus y squared over 16 equals 1. So the first thing is, if I don't have a visible denominator under x squared or y squared, I'm going to put this guy over 1. The reason for that is I'm going to need to use these denominators to again get my x and y intercepts. So for the x-intercepts, again, we learned the shortcut for that. So they would occur where? We know the y values are 0 in each case. What are the x values? Again, I look at this denominator under x squared. I take the principal and negative square root of that. So plus or minus the square root of 1 is plus or minus 1. So I get positive 1 and negative 1, right, as my x values. Then for the y-intercepts, we would get what? Well, we know that the x values would be 0 in each case. And again, I would just look at my denominator here. In this case, it's 16. I take the principal and negative square root of that guy. This equals plus or minus 4. And so the y values here would be 4 and a negative 4. So again, very, very easy to get these points going. I just take them down to the coordinate plane now. All right, so we would start out by plotting the point 1, 0. So 1, 0 is here. And then negative 1, 0 is here. And then 0, 4 is here. And then 0, negative 4 is here. So we have our intercepts plotted. And then again, we're just going to graph a smooth curve through the points. Again, the computer did a perfect job already. And I am going to, again, attempt to do a mediocre job by tracing over what the computer did. So let's go ahead and do that. Okay, so again, not perfect, but you get the general idea of what this guy would look like, and that's what you're looking to do. So just like when we saw circles that weren't centered at the origin, you're also going to see ellipses that aren't centered at the origin as well. So generally speaking, and this will change up based on if you have a horizontal ellipse or a vertical ellipse, but let's just use the formula for a horizontal ellipse just to kind of think about this. We have the quantity x minus h now squared over a squared, plus we have the quantity y minus k squared over b squared, and this equals 1. Now, if you had a vertical ellipse, the difference would be that this guy right here would be b squared, and this guy right here would be a squared. But again, to keep things simple, let's just work with the horizontal ellipse for right this second. The center will occur at h, k. Okay, so whatever's right here for h, and whatever's right here for k, but that's given that you have a minus sign here and a minus sign here. You've got to pay attention to that because if you end up with a plus something, you've got to make an adjustment to match the formula. So what we can say is that this guy shifts h units to the right if h is greater than 0. If h was less than 0, then what would happen is it's shifting h units to the left. Then we can also say it shifts k units up if k is greater than 0, or it would shift k units down if k was less than 0. All right, so let's take a look at x minus 3, that quantity squared over 9, plus we have y plus 1, that quantity squared over 36, and this equals 1. So the first thing is this guy will be a vertical ellipse. We know that because the 36 is larger than the 9, and 36 is underneath where the y variable is. Now that we've gotten kind of that out of the way, we think about how could we graph this guy? Well, if I was graphing x squared over 9 plus y squared over 36 equals 1, what would I do? Well, I know the center is at 0, 0. I know my x-intercepts are where? Again, I would look at this guy and I would go plus or minus the square root of that. Plus or minus the square root of 9 is plus or minus 3. So 3, 0, and then negative 3, 0. And then my y-intercepts would occur where? Again, I'd look at this. Plus or minus the square root of 36 is plus or minus 6. So 0, 6 and 0, negative 6. Okay. So I could plot those 4 points. I could sketch my curve around the 4 points, and I'd be done. What happens is this guy we're looking at here has been shifted 3 units to the right and 1 unit down. So the center will now be at 3, negative 1. You might say, well, where did you get that? Again, the formula is x minus h, that quantity squared, over, in this case, we have a vertical ellipse, so this would be b squared. But we take whatever's right here after the minus sign, so in this case that's 3. That is the x value for the center. Then we have plus, we have y minus k, that value squared. And then again, because this is a vertical ellipse, this would be a squared here, and this equals 1. But whatever this guy right here, if this was minus, we're taking that. Now, it's not a minus. I have a plus here. So I want to rewrite this as minus on negative 1, so it matches the formula, and I can just take negative 1 and plug it in as my y coordinate for the center. So now I know, let me just kind of erase this. If I scooch this up, I know that these points here have just shifted 3 units to the right and 1 unit down. Now they're no longer the x and y intercepts. They're just going to be, in the case of the x-intercepts, they just became the furthest points to the right and to the left of the center on the ellipse. For the y-intercepts, it's the furthest point above the center and below the center on the ellipse. So these are just 4 additional points we're going to get. So if I take 3, 0 and I shift it 3 units to the right and 1 unit down, then I would get 6, negative 1. If I take negative 3, 0 and I shift it 3 units to the right and 1 unit down, I would get 0, negative 1. If I take 0, 6, and again I shift it 3 units to the right and 1 unit down, I would get 3, 5. And lastly, if I take 0, negative 6, and I shift it 3 units to the right and 1 unit down, I would get 3, negative 7. Now each time I do this, I don't want to go through this comparison. So the easy way to kind of do this is to just find the center based on the formula. We know we're looking for h, k. We know how to find those values. That's my center. For points where we move horizontally from the center, I'm looking at this value here. So plus or minus the square root of that would be the horizontal distance from the center, again, to the furthest point to the right and to the left on that ellipse. So starting at 3, negative 1, I could add 3 to my x value and get 6, negative 1. And I could subtract 3 from my x value and get 0, negative 1. There's 2 points there. Then I take this guy right here, and now I'm thinking about getting a vertical distance from the center to the highest and the lowest point on the ellipse. Then plus or minus the square root of 36 would give me that. So that'd be plus or minus 6. With negative 1, I go up by 6, I get to 5. With negative 1, I go down by 6, and I go to negative 7. So that's how you could quickly get those 4 points. You grab the points. Let's start out with 6, negative 1. So that's going to be right here. We would have 0, negative 1, which is right here. So again, from the center, this is moving 1, 2, 3 units to the right, and 1, 2, 3 units to the left. Then we have 3, 5, so that's right here. And then we have 3, negative 7, that's right here. Again, from the center, I'm moving 1, 2, 3, 4, 5, 6 units up, and 1, 2, 3, 4, 5, 6 units down. So that's how I would get my 4 points. And again, I'm just going to draw a smooth curve through the points. Okay, again, not perfect, but you get the general idea of what this guy would look like. All right, let's take a look at one final problem now. So we have x squared over 49, plus you have the quantity y plus 4 squared over 9. This equals 1. So this guy, we want to start by, again, finding the center. And in this case, we have what? The 49 is bigger than the 9, so this would be a horizontal ellipse. So the center occurs where? It's at h, k. I just have x squared here. I don't have x minus something. I don't have x plus something. That quantity, I don't have that squared. So the center will occur here. The x value hasn't shifted. It's just 0. And to really write this in that format, you could say this is x minus 0, that quantity squared, over 49. So this guy right here is your x value, which is 0. Now for the y value, again, I want to write this as minus a negative 4. So negative 4 would be the y value there. And then to get my additional points, again, all I'm looking to do to get some horizontal points from the center, I just take this guy right here. I take the principal and negative square root of it. Principal and negative square root of 49 is 7. So I'm just going to move by 7 units to the right of the center and to the left of the center. So add 7 to 0, you get 7, then comma negative 4. Subtract 7 from 0, you get negative 7, comma negative 4. Then over here, again, I'm going to do the same thing for this guy. Plus or minus the square root of 9 would be plus or minus 3. So from the center, I'm now going to look for points that are vertically above the center and below the center. So my x value stays the same. Negative 4 plus 3 would be negative 1. And then again, my x value stays the same. Negative 4 minus 3 would be negative 7. So there's your 4 points there. So again, we're going to plot these 4 points. You have 7 comma negative 4. That's right here. And you have negative 7 comma negative 4. So that's right here. Again, in each case, from the center, we just moved 7 units to the right and 7 units to the left. Okay, so that's how we got there. Then we have 0 comma negative 1, and we have 0 comma negative 7. Again, from the center, we moved 3 units up and 3 units down. So let's go ahead and sketch the graph here. Okay, so again, not perfect, but again, you're just giving a general idea of what the ellipse would look like.